Anyway, I appreciate you doing this.
Yeah, my pleasure.
It's really, really a big help. So, what do you want the kids to learn in this lesson?
In this lesson, we're going to be focusing on algebraic expressions and introducing variables in algebraic equations. And the goal is for students to recognize that the value changes, right, depending on what number is basically substituted in for that particular variable. And so we're going to be doing some exercises, taking some notes and just doing some exercises, having some discussion about that.
So how are you going to teach this?
This is going to be actually pretty traditional with just some direct instruction. Today we did an activity that sort of introduced the concept of the use of variables, where kids were manipulating certain pieces from real-world problems and identifying key components, and then basically pulling those key components out and moving them around and converting them into mathematic algebraic equations.
Equations?
Yeah.
Okay. So it's going to be direct instruction. What is it that you would like me to look for in what you're doing?
Right.
So I can give you some feedback when we're done.
I think maybe what I'd like you to focus on is when we do have feedback, and kids, discussing the notes and the new content, and when we maybe do examples, focusing on questioning. That's one of my big goals, is to see how I can become a better math teacher through the questioning that I basically just give the students.
So you want to ask the right kind of questions to elicit?
To elicit responses, and the questions that will give students an opportunity to demonstrate their thinking, as opposed to just leading questions that will... I'm trying to avoid leading questions and focus more on genuine questions, and a genuine question being like something that I genuinely do not know.
So that when they do the thinking, it actually is their thinking, and the knowledge is actually theirs. They own it.
Exactly. So an example would be like, if there's a problem on the board, like 5p equals 25. Okay, so 5p, right?
What's the logic that you used? How did you construct? How did you go about figuring this out?
Yeah.
So that it gives them a chance to, because even if they don't know, they're going to have to figure out some language to explain how they did it.
Exactly, and that's what
So are you going to include any activities? Like, will students be working intermittently, or do you have a culminating activity that they're going to do?
We are going to start the class with sort of like a motivator, where we're going to get kids up front and sort of identifying certain things, and participating, like being a part of the math. But for the most part, this is going to be just discussion and lecture.
Direct instruction, and then there'll be times when you'll stop to do
give them opportunities to work through problems, discuss problems, and
to check in with them and see how they're understanding, how they're developing their understanding of the lesson. Okay, great. How will you know when your kids get it? And I guess that answers that question, doesn't it? You're going to be doing those spot checks as you move through.
Exactly. Yeah.
Okay, good. That sounds great. I'm looking forward to being here tomorrow, period 3.
Can't wait, man.
And seeing how it goes.
Perfect.
Thanks.
Thanks, bud. Activity that is going to relate around our essential question. Right? Our essential question is this today: how can we evaluate an expression that contains a variable? Okay, yesterday we worked with expressions. You remember that activity yesterday where we were manipulating the cards, moving them around, and working with algebraic expressions? Right? Yeah? Did that activity help you guys understand and sort of break down the word problems into sort of math problems that you guys can understand a little bit? Awesome. So today we're going to continue working with that. We're going to talk about algebraic expressions today. You guys just wrote down your homework. And before we get to this activity, we're going to need 3 volunteers. Okay, cool. Awesome. Yeah. A brief conference for about 20 seconds. While you guys are in here watching, I want you to bring your attention up here to the screen. And on the screen, we're going to display this. And I want you guys thinking quietly to yourself, what do you see up here, right? What do these things mean? And then when I come back from the conference, we'll get started. Here's what I want you guys observing and what I want you guys looking at as this demonstration sort of goes on. I want you guys thinking about what are these people doing, right? What are our volunteers doing, and how does it relate to this idea of algebraic expressions? What does it sort of mean? What is happening here? Okay, I want you guys just sort of observing what is happening here. You're just listening, there's no comments, right? Just listening, observing, and thinking. All right, our volunteers are going to be participating for about the next minute and a half. All right, Adriel, go ahead.
3 plus 14 is 17. 27 minus 3 is 24. 3 squared is 6. 9.
Well, thanks, Adriel. Next volunteer. You guys 30 seconds at your tables. We'll give a golf clap in just a second. But at your tables, what did you guys notice was happening up here? What were they doing? What was going on? You guys have 30 seconds to talk about it.
They were all different numbers, different answers.
The numbers they were holding were taking the place of the boxes. Okay, cool. What else did you guys notice? Yeah,
the volunteers were adding, subtracting, and multiplying.
They were adding, subtracting, and multiplying based upon the operations that we had, right? They were doing those operations. Man. Okay, there's all different numbers up there. So since these were all different numbers, and we took our volunteers each had, the same number, we said they sort of like replaced or took the place of or substituted those numbers in there because these numbers are different. What did you guys notice about the value of the expression?
I just noticed this about the numbers that are all prime.
Okay. In these cases, yeah, these smaller numbers, they were prime. Good observation. What did you notice?
That every time that the variable changed, the answer also changed.
Every time the variable changed, you use that term variable. Every time this variable changed, what do you mean variable?
It's an unknown number, and usually it's replaced with a letter.
Okay, sometimes it'll have a letter. In this case, it has a box. So you're saying that actually leads into what I was just going to do. Does this, if I took these boxes out, right, and I erased these boxes, and I replaced them with a letter, what do these letters mean? What do these letters mean? Yeah, bro.
They're a substitute for whatever number it is.
A substitute for whatever number it is. I'd like to use that term substitute. We are going to be talking today about algebraic expressions, and in algebraic expressions, all of these are examples of algebraic expressions. They have numbers, symbols, operations, and all of those things. And there's one special characteristic about algebraic expressions, that they have letters or symbols that represent numbers, like these unknowns, right? These unknowns. Cool. So for today, you guys, what we're going to be doing, we're going to be taking some notes. Okay, so yes, you are going to need either like a pen or pencil out in front of you. The other thing that you guys have in front of you is your materials box. All right, there are colored pencils and a variety of other things. You have the markers and the whiteboards. You are going to be using. I'll wait until I get all my directions before you guys start moving. What you guys are going to be using these for, right, is to help us with the notes and give you guys opportunities. During the notes, we're going to stop. You guys are going to be working with your partners, working some of these equations out. So, what you guys need right now to start for the notes. We're not using the whiteboards, we're not using the markers, but you will be using colored pencils. Right? Each side of the desk, you guys don't need 3 each necessarily, but maybe like, between the two of you, have at least 3 colored pencils that you can use because we're going to be color coordinating our notes today. You guys have 30 seconds to get that settled. And be nice about it. Right? Yes, if I see anybody grab it, use. Which one do you think is better to use? 4 times n using this symbol for multiplication, or 4 times n using this symbol for multiplication? You guys have 15 seconds. State your opinion with your neighbor. You guys can have your conversations and fun. Okay. So Kaden, what did you guys talk about at your table? Which one would be better and why?
The dot, because the the multiplication sign might be mistaken for a variable.
No, I like how you use the term variable too, right? The multiplication sign, this x right here that stands for the multiplication sign, could be mistaken as a variable. So now that we're doing...
How do you think it went?
Let's see, that particular period,
Yeah, to be honest with you, it was one of those lessons that you envision, at the beginning. You're like, okay, this is going to go pretty well, and you sort of envision like the amount of time that it's going to take. And we got through about, I think, maybe just over half of what I'd initially planned. And in terms of like how it went, I thought that it was, I would give it like a marginal at best, I would say.
Marginal?
Yeah.
Why? I mean, what did you think were some of the issues that came up?
I'm sorry, man, I'm gonna have to gather my thoughts about this. I'm really like blanking right now.
You don't remember it?
Yeah.
Yeah, we should have done this debrief right after.
Yeah.
Probably. I think that's a big lesson for me. And that's okay, because I'll keep this in my video,
Yeah.
and it'll be something that I'll learn. I really ideally should have debriefed with you right after the lesson or that afternoon, but our schedules have been so crazy.
Yeah.
Well, let me tell you a few things that I thought about the lesson.
Perfect.
Okay?
Yeah.
What I thought went well. I thought that the objective, the learning objective, was clear, and I thought it was just the right amount. Like, I didn't think it was too little or too much for them to grasp. I thought you really had it focused appropriately. I liked the pacing of the lesson. I thought that it was paced well. I liked how you used those notes and had them color code things as you went, so they didn't have to do an exorbitant amount of writing of notes. Yet they were still reviewing the notes and doing some writing on the notes, and I thought that was really effective. And I did feel like by the end, they knew the terms and they understood what those terms were. Now, I didn't know any of those terms before the lesson, but by the time that we were done, I did, and I thought that you scaffolded it really well.
Okay.
So, so I was pleased, And how much recall do you have of that day?
Yeah. Now that you mention it, in terms of like how the lesson went, with the color coding, the notes, I guess that I felt, with the amount of time, like you said, it probably was enough for them to grasp. And in terms of the pacing, like you mentioned, think about it, the way that I broke these notes down, showing them, instead of like, within this lesson there was 5 concepts, or like minor concepts that we'd be going over.
Right.
Instead of introducing the 5 and then practicing the 5
Right.
independently, I think the way that this lesson was structured was, mini concept, do some practice,
Yeah.
brief discussion, move to the next concept, right? Mini practice, brief discussion.
And then you gave them an opportunity to do some practicing
Right.
in their pairs,
Yeah.
at their tables, to reinforce the learning.
Yeah.
And then a lot of these concepts were just being introduced. And I thought that they were introduced successfully. I mean, I felt like the kids really grabbed them.
Okay, and
Were there whiteboards and
Yep.
markers? Okay.
Yeah.
So with the with the whiteboards and markers too, in terms of, I think when I was reflecting on that lesson, one of the biggest struggles I've had so far is just like establishing sort of structure, routine, and just like the what kids need to do in certain situations, right? And so
I think with that, this particular lesson would be, we probably would have been able to get through a lot more if the kids had a lot, like more experience and clearer directions from me, and maybe more practice with, like how we use the whiteboards, when we have our markers, what are we doing with them? And maybe that's, on my part too, maybe that's something that I just need to, like they are in 6th grade, like reminding them, every 5 minutes, these markers are math tools, they're not toys. you know, whatever it takes until they get it, you know, hopefully ingrained in their mind to use these things appropriately and efficiently, like with that time. Because I think when I was, when some of these students were working on these problems, I think a lot of them were, but if I do recall, like some of them were using material, like maybe not necessarily working on the problem when they should have been. Maybe they were drawing, using the whiteboards, you know, for drawing and stuff. So.
I didn't see too much of that, but I do understand what you mean about wanting to have more explicit routines with the materials.
Yeah.
And the process, you know, the process of using the materials.
Right.
And I think that you're right. I think that learning to be explicit about that, especially if you're going to use whiteboards and markers a lot, like the whole process of how we get them out, how we put them back, how we use them, the more that that's a routine, I think you're right, the more efficient the actual learning is. So that's, I think, a really worthwhile goal, or something to recognize about you know, teaching. And I think that we all feel that when we're using a lot of materials, you know,
Yeah.
for lessons, yeah.
Right.
Like, you don't realize how explicit you have to be and how structured you have to be about teaching them how to use the materials, especially the ones that you use frequently in your class.
Yeah. That is the truth.
That's an axiom.
It's an axiom.
That's a teaching axiom.
That's right.
But I wanted to get back to talking about what you said about using the practice in between the direct instruction.
Yeah.
I think that was a really good observation, self-observation. Like, I think you did a really good job balancing that. So you gave them just enough information, and then you gave them some time to practice in a couple of different
Right.
settings. And you were purposeful about doing that, right?
Yeah, I mean, that was the intention, right? You know, and like I said, we didn't get through everything I expected, so like, you know, whenever, I think, I don't know, with math.
And learning, you know, how to teach math, that's one of the things that I'm trying to, I guess, come to peace with, you know, find like, you know, because with math it's very structured, you know, you have to get through certain things within a certain amount of time. And so whenever I feel like, okay, we didn't get through that part, so now it's going to, you know, do I just cut that out completely? You know, how is that going to impact their learning later on? Because
Everything builds on itself. It's one of those things where I just have difficulty, I guess, justifying a lesson that doesn't go, like, I guess, according to the plan to keep up with the pace. You know? So, yeah, cool, if, you know, they got, you know, 60% of this stuff, great. You know, because granted, if we went through everything, maybe they would have only got 40%. Even though they were exposed to everything, maybe they only, like, you know, understood, you know, less than that. So, it's an interesting balance that I'm, you know, still learning about and trying to figure out.
Yeah, and it's, especially for math, with the sequencing and the pacing,
Yeah.
it's just a constant negotiation and constantly agonizing
word.
over your decisions about.
Yeah.
Well, yeah, because if you leave certain parts out, that's going to be a problem later.
Exactly.
It's so sequential.
Yeah.
So trying to figure out what is necessary, what the priorities are, how quickly you can move, you know, that kind, and then dealing with the reality of what are kids grabbing and not grabbing.
Yeah.
So I think that's another thing to acknowledge. That is a constant struggle, probably more so with math, I think, than
anything
the other,
else I've taught,
especially with this new
definitely.
math.
Yeah, and especially with what?
The new math. The new.
Oh yeah, yeah. It's interesting, to say the least. And I think one of the focuses that we were talking about was the questioning.
Mhm.
You know, I think that was one of the things that I wanted to focus on. And
you know, like reflecting on that lesson, this didn't necessarily, it might have lent itself to better questioning, but when it comes to like the direct instruction, I think
within that time frame, it was difficult for me to ask these authentic questions. And when we talk like authentic questions in math,
Right.
it means like questions that like the teacher truly does not know what the kid is going to say. You're not leading them to an answer. You're just asking them like authentic questions to get them to explain their thinking and how they came to that. So yeah, in terms of that, I definitely did not feel like I was able to get those authentic questions in. And I think, you know.
So you did use some questioning, so they were constructing some of their own knowledge. But,
Sure.
But do you think that maybe if the content were different, you'd have more of an opportunity to use authentic questioning? Because, you know, not every lesson lends itself to that, especially when you're giving basic information, like what these terms mean.
yeah, exactly. You know, and I think you're right, to a certain extent, maybe every lesson doesn't.
Right.
And I guess, I'm not necessarily sure which ones
Right.
lend themselves better or not. So whenever, again, like with what I'm trying to understand about teaching math and how, authentic questioning really is almost at the heart of getting kids to, to really understand the math. Again, because I don't necessarily feel like I was able to do that with this lesson, right? I question its effectiveness,
Because this, I guess, was more along like the traditional lines, teacher instruction, model, student practice,
Well, there wasn't much reasoning going
So-
on. They were
Right.
learning, you were teaching concepts,
Exactly.
not reasoning. So I think that there's a difference. Now, once you start using reasoning, once you start using these concepts and kids are reasoning and using them to do mathematics, that's a different kind of lesson. But you can't do that lesson without first having the concepts down. So I think that those kinds of questions lend themselves to different kinds of practices,
I didn't think
So,
of it that way, yeah.
yeah, and I think that's an important thing to recognize, because I don't think that there's a deficit here. I think you did a really good job with your questioning. So they were doing some construction, they were constructing their own knowledge about these terms, but this lesson is not really designed for that kind of abstract, and authentic questioning. Once they start doing reasoning and performing operations, then that will give you an opportunity to ask those kinds of questions. It's very easy for teachers to get caught up in this idea that we're always supposed to be using a certain mode,
Yeah.
but you can't get to the higher level abstract thinking without having the basic facts, without students having the basic facts and concepts.
Yeah.
Once those are in place, then you can start, and it's a progression. But we have this feeling like, oh, we're not doing what we're supposed to be doing, because there's such an emphasis in our district about doing that. That's not necessarily true. There's a sequence. Not every lesson is geared for that. You want to bring them to that level where they're doing all that, but there's a lot of scaffolding that takes place first, and basic information and knowledge before they start doing the abstract stuff, and
Totally, yeah. And I guess that's the balance, right? Like I'm trying to, the training that I've received, on this Common Core stuff, like everything's like so flipped, right? Is that they, they try and do the reasoning, and through the reasoning, right, understand the concepts. It's,
But when you're teaching terms,
right,
that
things
does
like
not
this, I
lend
suppose
itself
you're
to
right.
that, right?
Yeah,
Once you have those tools, then you can start doing, then the kids can start doing the reasoning and stuff.
yeah,
But you can't put the horse before the cart, you know what I mean?
right.
So, anyway, I appreciate this. I hope this was
Yeah,
helpful
totally.
for you. Was it actually helpful for you to think about, to reflect on this and go through
Yeah,
the
actually,
cycle?
yeah, definitely.